Firstly, I would like to discuss the topic ordinary differential equations. I don't want to go deep into the matters related to ordinary differential equations. So, I would like to discuss the topic ordinary differential equations as much as we need in the subject mathematics. So, for that purpose, we start these ordinary differential equations with introduction, formation of ordinary differential equation, and defining order degree of the ordinary differential equations. Before going to those things, we consider mainly the topic wise associated things. So how we go now we consider. So firstly we consider the thing ordinary differential equations. Firstly, I would like to introduce myself. My name is M. Nagireddy. My qualification is MSc Mathematics and Field and pursuing PhD. So I am working as a lecturer in mathematics in Government Degree College, Gambiraupet, Gambiraupet, Rajanna Sirsilla District, Telangana. So we consider firstly the chapter first order differential equations. So in first order differential equations, what we can have, what we can have. So in first order differential equations, firstly we are having the definition of a first order differential equation, and we find the order and degree. Later on we get the situation to find the to form the ordinary differential equation. All those things step by step we consider. Firstly, I would like to discuss a formation of ordinary differential equation. So how you form a ordinary differential equations? Firstly, we can be given a curves equation. So we consider firstly how many arbitrary constants in this curves equation we consider. Suppose we are given only one arbitrary constant, then differentiate the curve we differentiate the curve only once. And if we have two arbitrary constants, then we differentiate the curve two times. And if you are given three arbitrary constants, then we differentiate the curve three times. Like that, we differentiate the curve as many times as we are given arbitrary constants. Like that, after differentiating the curve as many times as we are given arbitrary constants, we get a relations. So how many relations we get? If you are given two arbitrary constants, two relations we get. If you are given three arbitrary constants, we will get three relations. So using these relations, we eliminate the arbitrary constants. After eliminating all those arbitrary constants, we get finally a relation which involves independent variable x and dependent variable y and the differential coefficients of y is equal to 0. Like that, we can have a function involving x, y, and differential coefficients of y. So that relation is called a differential equation. Like that, we can find out a differential equation. Forming differential equation, uh, what we are getting, we have observed now. Now, I would like to consider order and degree. Order, what we can have the definition of order. So, the number of the number of differentiations we do in the differential equation is known as order of a differential equation, that one. And the whole power of that highest order of differential coefficient is known as degree of that differential equation. Like that, we can have the order and degrees definitions. After having those definitions, now we consider linearly differential equation. What is the definition of linearly differential equation? For that purpose, what we do? We take a differential equation in the form of dy by dx plus capital Py is equal to q. Here, order of differential equation is 1, degree of differential equation is also 1. Here p, capital P is function of x, and capital Q is also a function of x. And like that, we are having following satisfying the conditions. What conditions? Order of differential equation is 1, degree of differential equation is 1, and p, capital P is a function of x, and capital Q is also a function of x. Like that, having the symbols and indications, if we have the differential equation in the form of dy by dx plus capital Py is equal to capital Q, then we say this differential equation is linear differential equation. So after having this linear differential equation, now we go to another thing also. Here in this differential linear differential equation, what we are having in this linear differential equation, what we are having? Order of differential equation is 1. Degree of differential equation is also 1. Capital P is a function of x. Capital Q is also a function of x. So, and x is an independent variable, and y is a dependent variable of x. So, like that, if you have another differential equation in the form of dy by dx plus py is equal to q, then we say this type of differential equation is linearly differential equation. So now we have to find the solution of this differential equation. So how we can find the solution of a differential equation? That is the main thing we have to consider. So firstly, we are having in the topic ordinary differential equations, solution of differential equation. That is the main thing. So firstly, what we have done, we are given a curves equation. So using that curves equation, we could find the differential equation. After finding differential equation, we defined order degree, and we have eliminated arbitrary constants. And after eliminating arbitrary constants, we could get the differential equations form. So after getting that differential equations form, firstly we are having the method linear differential equation and its solutions. So how to get a linear differential equations solutions? How to get a linear differential equation solution. That is the main thing we have to consider. So, how we find the solution of a differential equation? Before going to find the solution of a differential equation, first we have to find the integrating factor. Integrating factors definition, how we can find integrating factors definition, how we can find, that is the main thing we have to consider. So how, that is the main thing we have to consider. Integrating factors definition is e power, e means exponential function, e power integration of capital P with respect to x, with respect to x. This is the main formula of finding the integrating factor. Only if you could find the integrating factor, then only we can find the solution of a linearly differential equation. So, without finding integrating factor, we cannot find the solution of in linearly differential equation. So, what is the definition of integrating factor? So, the definition is given like this. Part definition: firstly, we are having a linear differential equation in the form of dy by dx plus capital Py is equal to capital Q, where P and Q are the functions of x is independent variable, y is dependent variable, then e power exponential function e power integration of capital P with respect to x, that means e power integration of p dx is known as integrating factor. So like this we are having the uh, finding of integrating factor. So after having that integrating factor, now we write the solution, general solution. How we can have general solution? So general solution is y into integrating factor is equal to integration capital Q into integrating factor with respect to x plus c. This is the general solution of a linearly differential equation. So, what formula we are having for finding the solution of integrate linearly differential equation? Y into integrating factor is equal to integration of capital Q into integrating factor with respect to x, that is dx plus c. Here what we know, y into integrating factor we know, we could find the integrating factor of this linear differential equation, and q also separated from linear differential equation into I of dx plus c. Here c is a constant. Which type of constant? A constant. Which type of constant? An arbitrary constant. C is an arbitrary constant. This is the formula of finding the solution for a linear differential equation. So here we have to consider one thing. I would like to introduce here a great phenomenon here. What type of phenomenon here we are having? In this topic, ordinary differential equations, in this topic, ordinary differential equations, we are having different kinds of methods. In ordinary differential equations, we are having different kinds of methods to find the solutions of different kinds of ordinary differential equations. What types of methods we can have? Suppose firstly we are having linear differential equation. Next we can have Bernoulli's differential equation. Next we have exact differential equation. Next we have the integrating factor in different kinds of forms. mx plus ny, mx minus ny, 1 by mx plus ny, 1 by mx minus ny. Uh, Next, 1 by m, 1 by m, taking the form some other in bracket, and 1 by n taking the some form in other bracket, like that we are having, and some more kinds also we are having. Homogeneous linearly, homogeneous differential equations, and non-homogeneous differential equations. Different kinds of differential equations we can have. So where we use integrating factor, in some cases we use, and in some cases we don't use. So homogeneous differential equation, and another thing, non-homogeneous linear differential equation, we don't use integrating factor. We don't use integrating factor. We no need have. And when we find the solution of a linear differential equation and exact differential equation, like that, when we are in the position to find the uh, solutions of linear differential equation, and some other forms we need, but in some cases we don't need. So firstly, we are having different kinds of methods, in which we use uh, sometimes integrating factor, and we don't need integrating factor. Like that, we are having different kinds. Firstly, we discuss the topics where we need integrating factor. So in especially linear differential equations, we need to find the integrating factor. We need. So firstly, in linear differential equations, the formula solution is y into integrating factor. Integrating factor is equal to integration of q into if with respect to x plus c. So like that, we are having the solution. So now we apply this method. We apply this method. We apply this method using the examples solutions. So first here we are having some more examples. What type of examples? Here, to find the integrating factors. Find the integrating factor of following four questions are given. So how to find the integrating factors of following four ones. So firstly, find the integrating factor of questions. You see, find the integrating factor of first one, dy by dx plus 2y tan x is equal to sin x. Second one, x dy by dx plus 2y is equal to x square log x. Third one, x square y dash means dy by dx is equal to 3x square minus 2xy plus 1. Fourth one, dy by dx is equal to dy by dx plus y cot x cosecant x, like that we are having. So integrating factor, to find the integrating factor, we are having the four questions. So how we solve for the purpose of integrating factor, we can see. Firstly, we take the integrating factor of dy by dx plus 2y tan x sin x. So for this purpose, we have to find the integrating factor. Now simply we write it in the form of linear differential equation. What form you can get? Dy by dx plus 2 tan x in a bracket into y is equal to sin x. This is a linear equation in y. This is a linear equation in y. we are getting here linear equations form. So compare it with dy by dx plus py is equal to q, where p, capital P and capital Q are the functions in x. So when we compare it with the above said equation, we get capital P is equal to 2 tan x and capital Q is equal to sin x. Integrating factor we get, integrating factors formula is equal to e power integration of capital P with respect to x. P is identified as 2 tan x. Then integrating factor is equal to e power integration 2 tan x dx. 2 is a constant, so we can write it outside the integration. Then we get only e power 2 integration tan x dx. Then simply we get then simply we get e power 2 log secant x, 2 log secant x. After getting e power 2 log secant x, it can be written in the form of e power 2 log secant x. This constant 2 can be in the place of power of secant x. Then e power log secant square x. So log and e, that means exponential function e and logarithmic function log, both are inverse to each other. So then simply we can strike off exponential function and logarithm function. When we strike off e and log, then simply we get integrating factor is equal to secant square x. This is required solution. So what they have asked us, so to find the integrating factor of the given differential equation. So simply we can uh, find out the integrating factor in this manner. So, okay. After completing the finding of integrating factor, now we find the integrating factor of another question. Another question. How we are having 1 plus x square in a bracket into dy by dx all plus 2xy is equal to x cube. X cube. So this one, how we find? This one, how we can find? So, what we have to find here? Integrating factor of this question here like this. So, how we write 1 plus x square simply with dy by dx. 1 plus x square is with dy by dx. Now we divide this complete equation by 1 plus x square. When you divide it by 1 plus x square, simply we get dy by dx plus x by 1 plus x square into y is equal to x square by 1 plus x square. Like that we can get. Like that we can get. So like that we can get. Now what we get? We got a differential equation in the form of dy by dx plus x by 1 plus x square into y is equal to x square by 1 plus x square. We compare it with linear differential equation. Then we get capital P is equal to x by 1 plus x square and q is equal to x square by 1 plus x square. Like that we could get. like that we could get. Now write integrating factor. We know the formula of integrating factor is equal to small e, that means exponential function our integration of capital P with respect to x dx is equal to e power integration of x by 1 plus x square dx. That one can be simply write 2 along with the x in place of numerator and divide this integration by 2, that means 1 by 2. So simply we get e power 1 by 2 log 1 plus x square. So 1 by 2 can be the power of 1 plus x square. Simply here we can get the form, we can get the form 1 plus x square by power 1 by 2. Why we are getting here only 1 plus x square power 1 by 2? Because exponential function e and logarithmic function, that one, both are inverse to each other. That's why simply we can strike off logarithmic function and exponential function. Simply we will get to only 1 plus x square power 1 by 2 integrating factor we could get. Now we have to find the solution. So solution purpose also, here we are having a formula. So solution purpose also we are having a formula. What formula? The general solution of above said linear differential equation is equal to y into if is equal to q into if with respect to x integration plus c. So y we know, integrating factor 1 plus x square power 1 by 2 we know. So wrote we have written it as it is equal to integration x square 1 by 1 plus x square into integrating factor 1 plus x square whole power 1 by 2 with respect to x plus c. So simply 1 plus x square power 1 by 2, 1 plus x square whole power 1 can be cancelled, and it can be written in the form of 1 minus 1 by 1 plus x square 1 plus x square whole power 1 by 2 with respect to x plus c. Like that we can write. And 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 we have to consider this one. Now here 1 plus x square whole power 1 by 2 means under root of 1 plus x square. Multiply the brackets terms with 1 plus x square whole power 1 by 2. When you multiply it, then we get to only integration of 1 plus x square with respect to x minus integration of 1 by root 1 plus x square with respect to x plus c. So we know the formula for the integration of formula of the integration of root of 1 plus x square, that is x by 2 root 1 plus x square plus 1 by 2 sin hyperbolic inverse x minus this one's integration is sine hyperbolic inverse x plus c. So again, now if you simplify, then simply we will get y into root 1 plus x square is equal to x by 2 1 plus x square minus 1 by 2 sin hyperbolic inverse x plus c. Like that, like that, we can have the solution of a linear differential equation. Now, okay, now, okay, now we could observe Now we could observe the differential equations definition and order degree of a differential equation and formation of differential equation and linear differential equations definition and what is integrating factor, how to find integrating factor, using integrating factor, how we can solve a linear differential equation. So, so all these things we have considered. Now, with here we can complete the topic in linear differential equation. So after considering this type of linear differential equations, now we go to another topic later on we will consider. So herewith we can finish the this today's topic. Completes today's topic. Thank you very much.